Welcome to the Deep Dive. Today we're jumping into a huge stack of sources, all focused on an area of commerce that's, well, it's becoming a massive strategic imperative.
Right.
We're talking about the shift to eco-friendly packaging in the cosmetics industry.
And this is not just an aesthetic choice, not at all.
No, it's a really high-stakes balancing act. You've got to think about performance, consumer safety, and, of course, the environmental footprint.
Exactly. For those of you managing production, maybe supply chains, you have to look at this holistically.
What do you mean by that?
Holistically.
I mean everything from the primary bottle that actually touches the product all the way to, the big tertiary boxes used for shipping.
Okay.
We're trying to figure out what criteria actually drive truly responsible choices.
To separate the real circularity from, let's say, just green messaging.
That's the goal.
So our mission for you today is pretty clear. We want to extract the core insights that leading brands and manufacturers are using right now.
We're aiming to give you a kind of blueprint for making sustainable packaging decisions that, actually hold up under scrutiny.
And that scrutiny is coming. If you track brand reputation, you know that circularity isn't a niche thing anymore.
Not at all.
It's a core driver. It impacts brand trust, cost of goods, even your speed to market. We have to understand how this whole decision process links material science, supply chains, all that technical stuff.
With legal compliance and how you talk to your customers.
Precisely.
Okay, so let's define our compass for this deep dive. Across all the sources, 6 critical criteria just kept coming up again and again. These are the pillars we can use to evaluate any material choice. First, recyclability.
Okay.
Then, recycled content percentage, that's PCR. Carbon footprint,
Right.
material safety and compatibility, crucial for cosmetics, end-of-life options, and finally, cost. Or, maybe more importantly, the return on investment.
And these aren't just buzzwords. I mean, these are the technical, regulator-ready components that turn a vague hope for sustainability
Into something real.
into a commercially viable and, defensible product line.
All right, let's dive into that first pillar, recyclability. Because I think this is where most of the confusion starts.
More definitely.
You look at the bottom of a container, you see that familiar chasing arrows symbol. But what are we missing? What's the reality behind that symbol?
We're missing almost everything. I mean, true recyclability depends on, 3 big factors.
Okay.
First, is the material compatible with your local recycling stream? Second, can the machinery in the facility actually sort it properly?
And the third?
And third, will the curbside program even accept it? Cosmetic packaging is often small, or it has leftover product in it, which is a huge problem for recyclers.
Wow. So a bottle that's perfectly recyclable in, say, Paris might just be landfill bound in rural Texas.
That's it. And that's a massive headache for global brands.
So what's the practical design goal then? How do you get around that?
Simplicity. It's all about simplicity. The industry is trying to move towards monomaterial designs wherever possible.
Meaning just one type of plastic.
One type of plastic. Minimize those mixed resin layers, get rid of complex assemblies, those pumps that have multiple plastics and metal springs.
Right.
If a sorting machine can just identify and process the entire bottle in one go, you've dramatically increased its chances of actually making it through the system.
Okay, so from design simplicity to the material itself, let's talk about PCR post-consumer recycled content. Why is maximizing that, using things like recycled PT and HDPE, why is that the low-hanging fruit?
Because it directly cuts the demand for virgin fossil fuels. It's a straight reduction. But here's the trade-off, the really interesting part.
Go on.
Brands have to balance getting that high PCR content, say 70%, with performance.
What kind of performance issues?
Well, with cosmetic formulas, especially ones with strong fragrances, trace contaminants in recycled plastics can cause some big problems.
Wait, trace contaminants could affect the fragrance? How?
It's all about chemical migration. Fragrance molecules are volatile, and they can react with tiny impurities left in the recycled plastic.
So the smell could change.
It could lead to something called odor scalping, where the package actually absorbs the fragrance so the product gets weaker over time.
Wow.
Or even worse, it could leach unwanted smells into the product.
Which is why you need that certified cosmetic-grade PCR.
Yes, which adds cost and adds complexity to your supply chain.
That nuance leads us right to the next pillar. Carbon footprint. There's this intuitive idea that lighter packaging always means a lower carbon footprint because it's cheaper to ship.
Right, the transport argument.
But if we take that holistic view you mentioned, what's the single biggest misconception here?
The misconception is thinking transport weight is the only thing that matters.
Okay.
Sure, lighter might save some fuel, but if that light, very complex package was made using high-energy processes and it's just going straight to a landfill because it can't be sorted,
Its overall footprint could be much worse.
it could be way worse than a heavier, simpler material that gets recycled efficiently.
So how do we measure that total impact accurately? What's
Yeah.
the tool?
The tool is life cycle thinking, or an LCA, a life cycle assessment.
Okay.
We have to look at materials not in a vacuum, but as part of a whole system. An LCA, which usually follows the ISO 2040 standards, it quantifies everything.
Everything.
From the moment raw material is pulled out of the ground all the way through manufacturing, transport, use, and its final disposal. It forces you to look at the entire value chain, not just one little piece.
Since that LCA shows that infrastructure is so critical, let's look at the materials whose fate really depends on that infrastructure.
Good idea.
For prestige cosmetics, glass is still the gold standard, right? It's chemically inert, which is great for product stability, and it feels premium.
It does, and glass has amazing end-of-life potential. It's infinitely recyclable in a lot of places.
And it's perfect for those return-to-refill systems.
Absolutely, especially in dense urban areas.
Yeah.
But, and this is the big but, when you run the numbers for the transport phase of the LCA, glass is heavy. Lifting a pallet of glass jars just burns so much more fuel compared to plastic. So the carbon emissions from transport are way higher.
Unless the consumer is really good about recycling that jar.
Unless that recycling loop is incredibly efficient.
Okay, so then we pivot to the materials that sound amazing on paper. The bio-based plastics. We're seeing things like PLA, PBAT, PHA.
Yeah, these are materials derived from renewable sources. PLA from cornstarch, for instance, or PHAs, which can be made by microorganisms.
They seem great. They reduce our reliance on fossil fuels.
They do. But the limitation, the huge one, is that they often demand very specific end-of-life infrastructure.
You mean industrial composting facilities?
Precisely. And if that infrastructure isn't available, which, let's be honest, it isn't in most of the world, they just end up behaving like normal plastic in the waste stream.
And what about compatibility with the actual cosmetic product?
That's the other hurdle. With active ingredients, these newer biomaterials can introduce some really severe challenges. Things like unexpected odor retention or...
Additives migrating from the package into the product.
Exactly. It's a really complex formulation problem to solve.
This whole thing sounds like a minefield. So why do good old PCR plastics like PET and HDPE, why do they continue to be the workhorse here?
Because they hit a kind of sweet spot.
A sweet spot between performance and
supply chain maturity. PCR, PET, and HDPE, they offer those big virgin material savings, but they can still maintain the clarity and the barrier performance you need for cosmetics.
But their success still hinges on.
It hinges entirely on robust local recycling and a really clear, documented chain of custody to prove where that material came from.
Before anyone scales up these new materials, whether it's bio-based or high PCR, we have to talk safety. What are the absolute non-negotiables for material safety that sometimes get overlooked?
The non-negotiable is inertness, period. The package cannot react with the product over its entire shelf life.
And what's overlooked?
What's often overlooked is what happens when you introduce a new material. Maybe a PCR plastic with slightly different impurities or a new bioplastic. You need intense collaboration between the packaging engineer and the cosmetic formulator.
To test everything.
Every single coating, every ink, every closure component has to be rigorously tested. You have to ensure nothing unwanted migrates into the product and puts consumer health at risk.
Okay, moving into design strategies. If you're a brand just starting this transition, what is the ultimate design baseline? Where do you begin?
The baseline, like we touched on, have to be mono-material construction.
Keep it simple.
Minimize complexity, maximize simplicity. It just makes the sorting process for recyclers, which is the biggest bottleneck, so much easier. But beyond that, the most impactful shift is designing for reuse.
Which brings us to the refill revolution. Modular systems, rechargeable formats. They can dramatically cut waste.
They can.
But this isn't just a design choice, is it? It sounds like a logistical nightmare.
It absolutely is. I mean, the success of a refill system doesn't just depend on a beautiful package. It depends on an entire integrated infrastructure.
Like, how do you process the returns?
Who manages the collection? The sterilization, if it's a true return to refill. And maybe the biggest question, will consumers actually participate? If they don't, all that complex design is just wasted.
I do see the value in modular systems, though. You can reuse the primary package even if you update the formula.
Yes, and that adds huge long-term value. Imagine a brand designs a beautiful, heavy, etched glass outer jar.
Okay.
They can just sell new, small, simple monomaterial pods that click inside. They can change the formula, introduce seasonal products.
And the customer keeps the expensive outer part.
Right. It amortizes the cost of that premium component over multiple sales, and it drastically reduces material use.
But none of this great design work pays off if the consumer at home messes up the sorting process.
That's the final, crucial link.
So clear consumer guidance is everything to make sure that perfectly designed package doesn't just end up in the wrong bin.
And precision is key. The guidance has to be clear, legible, and not misleading. Brands need to move beyond these vague claims.
So use standardized icons.
Standardize icons, simple language, and explain the right way to dispose of it in each specific market.
Because the rules change everywhere.
Because the rules are wildly different. Getting that right improves sorting accuracy and protects the whole waste stream from contamination.
Let's pivot now to the bigger business context. We mentioned LCA as the compass, but I want to go back to that example you raised. How does the hard data from an LCA actually force a manufacturer to change their assumptions?
It provides the non-emotional data. It takes intuition out of it.
Okay.
So take that comparison. A heavy glass jar with a PCR lid versus a standard lightweight PT jar.
Intuition says the lighter PT jar is better.
Of course, it's lighter to ship. But the LCA, which measures total energy use, global warming potential, all of it, it revealed a really nuanced truth.
And that was
In regions with really mature, high-efficiency glass recycling systems, the heavy glass option actually had a lower overall environmental impact.
wow.
Because the massive amount of energy needed to create new virgin PET far outweighed the transport penalty of the heavy glass.
That is a huge shift in thinking.
Yeah.
It proves you can't just make assumptions.
You have to look at the whole ecosystem.
And that kind of data is essential now because brands are navigating these huge converging regulatory shifts.
Indeed. We are seeing major jurisdictions taking a really hard line on this.
Like the EU's PPWR.
The European Union's packaging and packaging waste regulation, the PPWR, is the perfect example. It's explicitly designed to raise both recyclability and the mandated recycled content targets for everyone.
And for brands, this isn't just a suggestion.
No, this is a non-compliance risk. It could lead to massive fines or, even worse, being excluded from the market entirely. Brands have to adapt, and they have to do it quickly.
And when you make claims about complying or about how sustainable your product is, you need certifications to prove it.
You absolutely need verified proof.
So what are the key ones?
Well, if you claim compostability, you need the OK Compost Family certification. If you're using paper, you need the FSC Chain of Custody cert to prove the wood fiber is from a sustainable source.
The bottom line being...
The bottom line is that every single claim must align with rigorous, standardized testing to avoid misrepresentation and, frankly, to maintain any consumer trust.
Okay, so let's finally address the elephant in the room. Cost and ROI. Sustainable packaging, especially that high-grade PCR or the next-gen biomaterials, it often costs more upfront than virgin plastic.
It does.
So if you're a mass-market brand, how do you justify that cost to your shareholders without just relying on a temporary green halo effect?
That is the critical question. And the ROI isn't just from premium branding, though that helps in some markets. The real long-term return comes from 3 places.
Okay, what are they?
First, you reduce your exposure to the price volatility of virgin petrochemicals. Second, you avoid future regulatory penalties, which we all know are coming. And third, you can gain efficiencies from having a more streamlined monomaterial supply chain.
So it's really about future-proofing the business.
Exactly.
And how do companies manage the risk of that high upfront investment?
A staged rollout. That's the most common risk-managed way to do it. The example from the sources was a company that did a 12-month phased transition to PCR PET.
Across their whole line?
No, just across 5 specific SKUs. And they didn't start everywhere. They started in markets that already had mature, high-quality recycling streams.
To prove the concept.
To prove the concept, secure the supply of traceable PCR, and minimize their risk before they tried to scale that cost globally.
This has been a fascinating dive into some real operational complexity. So what does this all mean for you, the listener, who wants to put this strategy into practice?
Well, the sources actually synthesize a really clear 3-step process.
Okay, let's hear it.
First, you start with a baseline assessment and target setting. You have to audit 100% of your current packaging and set clear goals.
Like 50% PCR in all primary packaging within 3 years.
Something exactly like that. Second, You run pilot programs on just a few SKUs. You test everything: consumer acceptance, material compatibility, supply chain readiness.
And then the final step.
Then you scale the successful formats and you communicate transparently. You make sure you have total traceability and you align with your major retailers' sustainability programs.
That structured process seems key. Looking ahead now, what new trends are on the immediate horizon that could, fundamentally change this whole game?
The big focus is on materials that current mechanical recycling just can't handle. We're seeing incredible advances in chemical recycling.
Which breaks plastics down to their base molecules.
Yes, essentially creating virgin quality material all over again. We're also expecting next-generation bio-based materials with much better barrier performance to come online.
And better labeling.
And, critically, standardized global labeling systems. Something designed to finally eliminate all that consumer confusion.
That convergence. The regulatory pressure meeting the material innovation. That's what makes this so exciting.
It is.
So here's the thought we want to leave you with. Given that the global regulatory landscape is converging toward higher recycled content targets and clearer recyclability criteria, how quickly will innovations like chemical recycling move from pilot programs to scalable, commercially viable solutions that can truly bypass the limitations of our current infrastructure?
That is the billion-dollar question. The pressure is on. It's no longer a conversation about if companies should change, but how fast they can scale these new solutions.
Thank you for joining us for the deep dive. We hope this gave you the clarity you need to navigate the packaging ecosystem from a truly informed and strategic perspective.